Okay, so how does regularization exactly impact the cost function? So in regularization, as we talked about, we want small values of W1, W2, all the way through Wn, because this simplifies our model and it makes it less likely to overfit our data points. So we'll have a smoother curve overall. And we do this by penalizing or shrinking all values of Wj because we don't know which ones are most important or will have the most weight on our model. So what we actually do is we add a regularization term to our cost function. So here, we're adding our regularization term, which incorporates a term called lambda, which is the regularization parameter, and it's greater than 0, and it's like our learning rate, where you have to choose its value. And then we divide it by 2m to stay consistent with this part of our cost function over here, and we loop through all of our features, so we're going from 1 through n, that's the number of features, and we're going through each w parameter. So now in our cost function, we want to minimize both terms. Now we have two terms. We have the mean squared error part of our cost function, and this ensured that our model fit our data well. Because remember, we're comparing our predicted output versus the real value. And then our regularization term is ensuring that we keep j small, we keep our parameters small to avoid overfitting. And lambda, what it does is it actually balances these two goals. Now let me show you what I mean by this. So say we choose a lambda value of 0. Well, if our lambda value is 0, essentially this term just cancels out and we're only left with the mean square error. So that means only fitting the data will matter. And if we were to plot that, now our model will be overfit. So it'll look something like this, where we're overfitting our data again. So this isn't actually the best model because we basically ignored our regularization term because we set lambda equal to 0, and we're just talking about the mean squared error here in our cost function, which is the problem we had before, overfitting. Now let's say we choose a lambda value that's really high, something like 10 to the power of 10. Well, when our lambda value is this significant, now this term is essentially going to be ignored. Our mean squared error term is essentially going to be ignored, and we're only left with the regularization term. And remember, the regularization term ensures that Wj is small. So now we don't really care about fitting the data as much. Now we really care about keeping Wj small. So essentially, these terms are all going to approach 0. And really the only term we're left when we do that is b. So when lambda is extremely high, our model is really just going to be a horizontal line at b. So it looks something like that. If that's b, now our cost function will look something like that, but it's just a horizontal line because we ignored mean squared error, and now we're only looking at the regularization term. So the reason why I illustrated this to you is to emphasize the fact that we want a lambda value that balances fitting data and minimizing Wj. And when we do this, we'll have a model that looks something like this, where it's fitting our data well, but it's also minimizing Wj.